Welcome to Exceptions in Java. They were designed to help us handle errors and exceptional events. So let's define what exceptions are while we start. If there's an event in your program that disrupts the normal flow of what you're instructing the program to do during its execution, that is an exception. Now, so far we've understood some things that will help us in understanding exceptions. So let's start from what we've covered so far in this playlist. So when you make a call of a method in your main method and you run the main method, when it's executing, that call will be made to the method and then execution will proceed from there. So let me demonstrate this to show you what I mean. So in this example, we have class example here. Within class example, there's the main method. Execution starts from the main method. So inside the main method, there's this line that creates an instance of our class example. Yeah, and then there's this line that makes a call to method example via the instance of the class example exception. Now, what will happen is from the main method, from this call, it will go, the execution will follow to the executing the method example one line up to the last one, except when you have control flow statements, which we've talked about in a previous session. With that knowledge in mind, then when I refer to the call stack in exceptions, you will understand what's going on because they operate by the same way. This is a simple diagram for a start, but we'll look at a better diagram here after we've looked at code examples in try-catch. The method where an error has occurred, how it is usually handled is it creates an exception object and then it hands that to the runtime system. And this process is called throwing an exception. So it throws an exception. Now, that exception object usually has information about the type and the type of the error and the program state when it happened. Please focus on the type because we will review it. After throwing an exception, the way exception handling occurs is in the opposite direction from the call stack method calls. So it starts from where the error, the method that threw an exception, and then it goes to the method that can handle that exception, or it will go downstream until it finds the appropriate handler for that error. Now, basically, it's looking for an exception handler. Those are the terms that we need to familiarize ourselves with when it comes to the exception handling in Java. So it will then pass that exception or the exception object to the handler, and it must be the handler that is of the same type. This is why I was telling you to focus on the type, but this is just the first step where we are looking at it. It has to be of the same type as the exception object, because remember the exception object has the type and the status of the program at that time. So if it finds the right handler, then we will say that it has caught the exception. The handler has caught the exception. So we'll be looking at try-catch blocks, so it will be easier to follow along. Now, speaking of exceptions, there is something in Java called honoring the catch or specify requirements. So there are certain types of exceptions that must be enclosed by a try-catch or a try statement or a method that throws a particular clause. We'll look at very many examples, but we'll go step by step code examples in this. So for certain types of exceptions in Java, if you do not use a try statement or a method that throws a clause, then it doesn't compile. There are many examples to come on this. So let's talk about the types of exceptions then before we proceed to that. We have the checked exception. The catch or specify honor is a must. So this is because if an app is well written, it should anticipate some things. So it applies on errors or events that can be anticipated and recovered from. Things like when you're reading from a file, when you're writing from a file, or interacting with some resources, as we'll see in our upcoming example. With then checked exceptions, there are two types. There is error and its subclasses. and this applies to things that cannot be anticipated, like hardware failure. Catching them is optional. And the next one is runtime exception and its subclasses. Again, this one occurs with internal exceptions, but you really can't anticipate or recover from, so it's also not a must. Things like logical errors, bugs, or improper use of API. So you need to go and look at the code and see what you can fix. If it's coming out of a logical error, fix the logical error. If it's coming from a bug, fix the bug. If it's coming from an improper use of an API, then you need to fix that. I got this diagram from the official source whose link is in the description. Yeah. So we have the object class, the overall, then throwable after that, then throwable has subclass error and exception, and in exception there are checked and unchecked runtime exception. Let's go have a look at what they are in code step by step. This might be a long one before we come and finalize these diagrams. On the top with the list number. Now there are some java.io classes that will be featured here, but they will be covered in later sessions. So for now, let's just focus on the exceptions bit of it. Okay, we have a list of integers and we have a size that is constant. Here, list of numbers, and what list of numbers is doing is it is initializing this list into an array list by that size and iterating through it one by one until when it gets to 9 or element, the 10th element, which is a 9, from 0 up to 9. Okay. Now there's another method here, write list, and in write list is where we'll get to see the importance of try-catch block in Java. Now the file writer constructor throws an input-output exception if that file cannot be opened. In this case, if the output file cannot be opened. Now, the input-output exception is a checked exception, and checked exception must catch or specify, must honor catch or specify. So it must be caught, and if you don't catch it by one of the two ways, one way being using the try-catch block, another way is working with the throw clause in this method, then you will see this error here in Java, and you'll see that it's actually suggesting that you can either add a method signature, or you can either surround it, or you can surround it with a try-catch block. So we'll walk through this. Within that method, we have this for loop that is iterating through the list, and while it's iterating through the list, now it's working with this instance or the print writer, and it's supposed to print the value at a particular index on that list. Okay, so the getInt method is from the ArrayList class. It throws the index out of bound exception. So we have two exception statements. This one is applied, or it will occur when you're either working with a very small, that is a negative number value, or you're working with a large number than the array list, okay, than the size of the array list. So unlike the input-output exception, the index out of bounds exception is an unchecked runtime exception. Honoring catch or specified is not a must. 1, 2, 3. Honoring catch or specified is not a must, but it is recommended that you do that. Then after that, we close the open resource. How do we fix this then? We've seen two ways of doing it. The first way being working with the try-catch block is the one that we'll start with, or try statement. Then the second one being that you work with a throw clause on the method. So I'll just comment this out so that when we run some things later, it doesn't cause us errors, and proceed to step 1. So step 1, the first step when you want to create an exception handler is to work with to create a try block. And the try block looks like this. So it's try the opening curly braces, the closing curly braces, then anything in between that throws an exception. So after that, then you will have your catch and final blocks after. So first of all, we start from the top with a try block. When you're creating a try block, you can decide to separate the different exceptions. Like in this case, we have two. There's the input output exception, then there's the index out of bound exception, right? Now, one way of doing this is to decide to separate them in different try catch blocks. So try for this one and then catch it, and then try for this one and then catch it. But because these are very few, we'll just include them into one try block. Then we'll catch them in different catch statements, as you'll see. So everything that we expect should have an input and exception, then we are including that in the try block. Okay, but that's not the end of it. The try block accepts a catch block, hence this error, before we proceed to discussing closing. So because I wanted to go step by step, I'll comment this out to proceed to step 2. So step 2, here we go, is to work with the catch block here. Now in our example, we have two exceptions that we need to handle. So you need to have arguments passed into the catch block for the exception type and name. So this could be, index out of bound exception for the index out of bound one, then input output exception for the input output exception one, like we will see. So this is the second step. You have the try block here as the first step, then you catch statements here. Alright, although I'll show us also how you can combine the catch statements into one and what comes out of it. So we still have our try block here. Then after the try block, now we include the catch block that is supposed to catch the exceptions. So the index out of bound exception, just printing an error message, but it can do way more than that. Depends on what you're trying to accomplish within your catch block. And the input output exception that also prints an error message. Okay, so we are left with the finally blocks that we'll explain in the next step. And at this point, I can run it so you can see an outcome. There are no errors in our code. Entered try statement, as you're seeing here, is the output that you expected to see with the try block. So there's no exceptions that occurred, so we're doing okay. So if I was to break this, so you can see the input output exception that has been caught by the catch block, I can remove this output file right there, and then I run it. So if I run this, I expect that it will be caught by the index out of bound, the input output exception, and then we should see the error message. So here we go. In this particular case, the order of the errors, error handling does not really matter because they are unrelated. This one is unchecked, this one is checked. But if you're working with the same type, then make sure you work with a more specific handler here first before you proceed on to one that is not as specific. Okay, so step 3, we now have we are now looking at how we can combine the index out of bound and input output exception into one catch block, the same way we combined the exceptions, the code that could potentially throw exceptions into one. We can also do the same here. So this is the format. You check the name of the first, the pipe, and then you put the last one, then the name of the argument, and in this case it's E. Then you print all the errors in there. Okay, so you can also, as you have combined the potential code that could cause exceptions, then you can also combine the catch block arguments. So moving on to the finally block. Before I walk us through the finally block, I need to let you know, I forgot to tell you in the previous part, that last I checked, when you're working with this kind of arrangement for your catch blocks, then they must be unrelated. Like in this case, it makes sense. Okay, moving on. Now, there are three things that you would expect from this occurrence of the type and catch block. Yeah, so we could either have an exception thrown by this input output exception, and in that case it will be caught by this, or we can have an exception thrown by this, and in that case it will be caught by this. Yeah, so in each case, in any of the exceptions thrown, even if it's both of them, then after the catch block, the final block will run. Yeah, okay. Now, if it happens that there's no error and the try block runs, then the catch block will not, neither of the catch blocks will run. Okay, and after that, the final block will run. So really, the finally block always executes. Yeah. Okay. Now you can work with the finally block outside of exception handling to close your or to clean up your code. So like in this case, we are closing this. Yeah. We are closing this. Yeah. All this done within an if-else block. We've talked about this. So if it's not null, then close it. Otherwise, say that it's not open. If f is not null, then close it. So this is an if-else block. Then we have an if block here to handle the file writer. Let me just separate that to make it clear. But in Java, this is not recommended when closing a resource, or say closing a file or closing a resource, because it can result into a source leak. Okay, so there's a better way of doing this, which is to work with resource, try with resource statements instead. But you can fix that by including a throw clause in this method, throws EIO exception. There you go. It's fixed, yes, we could say, but it's not recommended. So take note of that. So let's check out try with resource statement. I'll comment this out. So everything is still the same as we've done it so far, but instead of working with this code that had an issue with the clause here, I will be working with the try with resource. And this is the try with resource. You have the try statement, and then a keyword, then parenthesis. Okay, and this is the close of that parenthesis. So opening and closing, please take note of that. Let me just mark this. It's the opening one, and this is the closing one. We're instantiating our file writer, and then we are passing that into the print writer. Still within the parentheses, these two statements are separated by a semicolon. Then we have now the try block. Okay, so I know it could be too much. In fact, let me just do this so we don't miss out. This entire thing is the parenthesis of the try after the try statement. Then this is within the try block. So within the try block, then you can pass in the other part, the other bit that had index out of bound exception. So when you do this, you will need to specify that this method throws an exception, and in this case it will be the exception that is a checked exception with the Honor system. So let's look at my examples. Okay, from the top we have this method here that is throwing an exception, input output exception. Now in that method there is this try with resource with the file reader here and the buffer reader here. So again, let me just make this simpler for you so you can follow. This entire parenthesis is with the try statement. Then within the try block we have this. So of course, the method throws an input-output exception. Same applies to the rest of them. Please make a point of going through this so you can fully understand the try resource, because this one here shows us an alternative. This method here shows us an alternative. Again, we've built up from when you're working with the finally block, and then when you're working with the try with resource here. So with the finally block, if this is the case, then you just have your method here, then you will have your readers here, then your try block, then your finally block. Don't bother opening up the comments in the main method, because they're not really doing anything unless you want to go all the way when you're practicing to include a file path, to also include another file path, or a zip file and an output file name, and a logical array connection. So if you're up to it, you can do that. Just include them there for a team that would like to proceed on to understand more about try with resource statement. Finally, with the long story, this is what we have. So there is our try block here, our catch blocks, and our finally blocks with the clause that makes sense. One or two things could happen. Let's start with if it fails and throws an exception. So if the try block fails by throwing an exception, this exception for example, then the next thing that will happen is to go through the call stack in reverse. The runtime system will go through the call stack in reverse until it finds the handler that can handle it. So in this case, it will be from the file writer constructor to this write list method here, then to the index out of bounds exception here, the block, then finally to this one. Okay. Then after that, it will go to the finally block, which executes no matter what. But please note that the file writer was never opened, so it doesn't need to be closed. So it will go to the else statement instead. Okay. Now the other thing is if everything succeeds, so only the try block will run. There will be no catch blocks. Then the final block, specifically this one that closes the print writer. That's that. Let's see. If it runs successfully, we are entering the try statement and closing the print writer. Yep. With our finally block again, we are entering the try statement, then we are closing the print writer. So how do we do this? Using a method with a throw clause. We can just include our method here and work with the throws clause and include our two exceptions so far. Then we have our code inside here that does what it's been doing so far. You might consider using this if you can't anticipate what the users of your package are going to do downstream, or all of their needs. So you can just let them know via your method that it has code that can potentially throw an exception that they need to handle downstream. So here we go, throws input output exception, throws index out of bounds exception. Okay, now because only one of those exceptions is the one that requires either for you to specify or catch, then that's the one that you are required to include the input output exception. For the other one, you can just let it go because it's an unchecked exception. That is it. But before we close, I'll walk you through this now that we might have understood it better. When there's a method where the error occurred, then the runtime system will be looking for the appropriate handler. If it meets an handler, like maybe if you're working with an input output exception and it first meets the index out of bounds exception, then the exception will be forwarded, so until it finds the correct handler for that particular exception and handles it accordingly. See you on the next one.